Assalamualaikum and hi, welcome to Techtronics, developing technology for a better world. My name Hussein bin Basri, matric number 63248, and today we will present our new product, which is Carrot Band, which is a device for heart rate detection for elderly care. So first, let me introduce our company, which is Techtronics. Actually, this company focuses on technology that will benefit the elderly. So we are specialized in elderly care system. Most of our technology consists of hardware and software. And this is our team. I am the CEO, and we have our COO, CTO, and CFO. For this presentation, it's divided to 5 parts. And this is the content for today's presentation. The first one is about elderly home care in Malaysia. So, along with the aging nation status, the number of elderly home increasing, especially in urban areas such as Johor, KL, Selangor, and Penang. Why? It's because they want to cater the demands from the working adults who cannot provide caregiving for their elderly parents. And usually these institutions are either operated by the Department of Social Welfare, NGOs, or by private sectors. So based on our visit in elderly home in Kuching last year, we managed to obtain 2 problem statements. The first one is that the nurses cannot keep track with the elderly health for 24 hours, so they cannot know immediately if an emergency occurs, since the place have two floors for them to cover. And the problem we talk about is about heart problem. So our objective, we want to provide the remote heart rate monitoring system for the elders in the elderly care homes, and we want to develop monitoring device to ease the nurse in taking care of elderly. And the parameter that will be monitored is heart rate in BPM during moderate intensity physical activity. And some of example is brisk walking, jogging, and gardening. So why we want to measure this parameter? We should know that as the person getting older, the heart capability will reduce. So if they do any vigorous activity, the heart rate will easily go to the maximum heart rate, and it will cause dangers to its heart. So we want to solve this problem. Furthermore, remote monitoring system have not been implemented in elderly home. So implementation of this system can enhance the elderly care system in Malaysia.
Hi, my name is Imran bin Muhammad Zaki. My matrix number is 63257. The next part is the methodology. The methodology is divided into 2 parts, the software and also the hardware. The first one is the software. The first software used to create this project is Arduino IDE. It is used to compile codings and upload it to the microprocessor. The second one is called Blink app. This is the software used to create the mobile apps to link with the device. It is an open source platform to create app for Android and also iOS to control microprocessor. Next, this is the list of components. We have 6 components in total. The first one is the Node MCU ESP8266 microcontroller. I know the name is very long, but this is a very efficient microprocessor. It is used as the brain for this device. Okay. Second one is the heart rate sensor. It is used to detect heart rate for humans. The third one is the 0.96 OLED display. It is used to display information such as heartbeat to the viewer. The next one, the fourth and the 5th component is the buzzer and also LED. It is used for notification purposes if any emergency or abnormalities happens. The last one is 3.7 volt battery used as the main supply for this device. Next, this is the block diagram for this device. The input data is taken from the heart rate sensor and it will be processed by the Node MCU ESP8266 or the brain for this device. The heart rate value is being output to the OLED display. And if any emergency or any abnormalities occur, the buzzer and the LED will be turned on to notify the caretaker. Okay, so this is the Carol Band initial design. We should have a custom PCB, as you can see the green one, a 3D printed enclosure, and also a watch strap for this device. But due to COVID-19, we are unable to create this design. The current design is only created on a breadboard. So, this is the circuit design for the Carol Band. We have a 3.7 volt battery as the supply, Note MCU ESP8266 as the main brain. We also have OLED screen, LED, and a buzzer as the output. Okay, so maybe some of you guys maybe wonder why we use ESP8266 instead of Arduino Uno or Arduino Mega or something like that. Because ESP8266 is more cheaper, it has a higher core, higher RAM, and it can do much more work compared to Arduino. So we pay less to get more. Okay, and lastly, we have the heart rate sensor as an input. Okay, so this is the formula used to create the maximum limit for a person. Okay, so the formula is 220 minus h times 64%. This is the equation that is being used to find the heartbeat limit in our coding.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Amar bin Khairul, batch number 63095. For our presentation today, I will cover for the result part. And for the first, here is the full prototype for our project, where previously our planning is to have the prototype for the smartwatch. However, there's some limitation during this COVID-19. Thus, we have done the prototype using the breadboard. Other than that, this prototype also linked with the Blink app, whereas here you can see is the GUI for our Blink app. GUI stands for Graphical User Interface, and if you can see in our Blink app, there is only one parameter that you're going to observe, which is BPM, which is beats per minute of the user. Now, if you can see, here is the initial condition where if the user have buy this product, they need to have a smartphone for Blink apps, and the breadboard itself is for his smartwatch. And if you can see, there are two things that we're going to observe. First is the OLED display, and second one is the parameters in the Blink app. And if you can see, the both reading shows 0 BPM. When the user put his finger on into the prototype, if you can see here, the sensor will detect his heartbeat and it will transfer the data to the OLED display. And if you can see, the OLED display shows the heartbeat for the user is 60 BPM. At the same time, if you can see the heartbeat through the Blink app, and the value between the OLED display and the Blink app are same. However, in some emergency cases where the prototype detect the abnormalities of the heartbeat of the user, the prototype will trigger the components such as LED and buzzer in a way to notify the user about the abnormalities in the heartbeat. Next, and it also will notify the user through the Blink apps by giving the notification. And as you can see, here is a notification when the abnormalities has been detected in the user. Other than that, we also have come up with the experiment for us to identify to find the accuracy for our heartbeat, where we're going to compare with the commercial model, which is the Xiaomi Mi Band 3. And as a result, we can see the accuracy for Mi Band 3 is 99.12%, while our prototype, which is Carol Band, is 98.03%. And it's a proof that our prototype are ready to be commercialized specifically for elderly care health system. So here is the demonstration or simulation video to enhance your understanding about our project.
Hi, my name is Imran. So today, we're going to test this Carol band prototype. The first test is, we're going to test on the resting heartbeat. So as you can see from this picture, I put my finger on the sensor. You can see the result that my heartbeat is 72. Next, we're going to test an extreme condition of heartbeat using this Carol band prototype. I have jogged for about 30 minutes and my heart rate has increased. So let's check on the Carol band prototype. As you can see, my heart rate is increased and the LED and also the buzzer is flashing rapidly. It also sends notification to the phone. So this does prove that the Carol band works to detect the patient's health. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Nur Kamalia binti Mat Elias Lauren. My metric number is 63621. Today I will be presenting on the costing and the conclusion part for this project. Okay, let's start with the costing part first. The table shows the list of components and things required for this project and the price for each of them. So the total expenses that we spent on the components alone are 74 ringgit and 20 cent. Notice that here we used not MCU ESP8266 board instead of Arduino Uno because it is much cheaper, which only costs 18 ringgit each. Other than that, we decided to use Arduino IDE and Blink's application because it is totally free. And yes, we have to follow strict budget. Therefore, we can come out with the low-cost product. Move on to the next slide. Here is the project utility cost, which include electric consumption, internet data, and the components delivery. So the total expenses are 245 ringgit and 30 cent. Yes, it is a huge amount, but it covers the whole process and time that we took to finish this project, which is 2 semesters. After considering all the expenses, which is the utility cost and the component cost, we decided to sell the product for 180 ringgit each. To calculate the profit, we take the selling price, which is 180 ringgit, minus the components cost per product, which is 74 ringgit and 20 cent. Therefore, the total profit for each product is 105 ringgit 80 cent. Okay, for our income, first we expect to sell 150 units of this product per month. So the estimated sales would be 15,870 ringgit. Divided by 4 because there are 4 of us in this group. So the expected income per person per month is 3,967 ringgit and 50 cent. Okay, now we are on the conclusion part. First is the project limitations. I believe every project has its limitations, and for our project, the final outcome of the product should be a wristband, not just the components connected on the breadboard. But yeah, due to the pandemic COVID-19, the MCO and whatnot, we cannot access the uses of 3D printing and the PCB soldering at the faculty. And next, the team meeting is limited to virtual meeting only. Okay, last but not least, the future recommendations. To improve this product, I think we can add the QR code that links to the medical history of the patients. It will be very helpful to the nurses, the staff. And the second one, we can add few more parameters to the product, such as body temperature reading and body oxygen level reading. Okay, that's all from us. Thank you very much.